Hi. Okay. Oh, cool. I got the loud voice again. All right. Okay. So my presentation is called WebGL What the Hell? So what the hell is WebGL? It stands for Web Graphics Library. And to me, this is an overly generic name because it could apply to Twitter Bootstrap. That is a web graphics library if you install it with the icon set. It applies to something that makes animated GIFs. But that kind of gives you an idea of its antiquity. Well, I'll just get to it. The genericness reminds me of the movie Repo Man, which everyone should see, by the way. You should just see this movie. He goes over to his folks' house and he's like, hey mom, hey dad, I'm just going to get a can of food. And then he goes to the fridge or whatever and gets a can of food. And that's just what WebGL's naming and its genericness reminds me of. Likewise, when they go to get drinks, it just says drink on it. Anyway, WebGL's name comes from OpenGL, and OpenGL has this very long history that basically goes back so far that not only is GL like, oh my god, a graphics library? Let's do that. It comes from this time when that was a big idea. It also is so old that it actually has its own name for constants. It calls them uniforms. But it is still happening today. CSS3 transforms and animations in WebKit are implemented as OpenGL, at least in Safari. There's a lot of filler in this because I wasn't sure I was going to figure out WebGL. So long story short, this is a sophisticated domain, and it is valuable to have domain knowledge. This is the logo for Cinema 4D, which is a 3D modeling program. And I'm just going to show you how that works real briefly. Okay. So here we have like a space, right? So it's just like a wide open space. And you pull down like a menu and you get yourself a sphere, right? And you can make the sphere bigger. And when you make the sphere bigger, all you're doing right now is you're telling the software, I want a sphere, and all I'm going to specify is the radius. So it's this kind of parametric object, right? And it's got a whole bunch of them. It's got cylinders, right? Here's a cylinder, and this will come back to code in an interesting way, or at least in some way, which I hope turns out to be interesting. But this is, like what you can do with these things. You make these cylinders, you can move them around, and this is the domain that WebGL, well, it's one of the domains that WebGL is modeling, and it's the domain that I find most interesting. So another thing you can do with this is you can do little Boolean operations, right? So you can say, like, give me the sphere minus the cylinder, right? And I think that's what's happening here. Yeah, and you can move them around like that. And let's see. Everyone seems bored, so I'm just going to skip that part. This is where you can end up, right? This is a TIE fighter, right? This is another TIE fighter. I got really into making TIE fighters. I've just been, wow. Because the thing is, all it is a circle and two hexagonal plates next to each other, and wow, it's a spaceship. So yeah, here they are, right? And this is going to be a TIE fighter in a web browser. Let's see. Yeah. Okay, so there it is. Woo! So the way this was created, right, is I went in that modeling program and I built a model. And I exported the model file, and then I loaded it in this, some JavaScript. So I'll get back here. Okay, so demo TIE Fighter in web browser. I don't know if you can see it. You're actually not supposed to. These are my notes to myself. So don't read those. It's cheating. Okay, anyway, domain knowledge. It's good to have domain knowledge. One of the things I was showing you here is parametric primitives, right? A sphere is defined only by having a radius, right? You don't have to do anything else. The cylinder has, a radius and a depth. And these things are, you can define arbitrary sizes just with the parameters. You can do Boolean operations. The wings are typically made by like extrusion, where you draw something in 2 dimensions and then you just extrude it into the 3rd dimension. And when you do something like that, I don't know if you can see it, but there's these little dots. I'm going to try not to walk over there and show them to you because it drives Omar crazy. But you can see these little dots over here, right? These are vertices, singular is vertex, and they define faces or fragments if I understand correctly, the WebGL term is fragment for this. Obviously, portable file formats are part of it, but it's a sophisticated domain, so it comes with a sophisticated vocabulary. And I know there's someone in here who understands it better than I do, because I was talking to him earlier, but maybe he ran away. I don't. Oh, there he is. Yeah. So if you want to find out if anything that I'm telling you in here is actually accurate, you should ask him, because he'll tell you if it is or not. I certainly plan to ask him. So what you have over here, though, let me back this up. This is a diagram of the graphics pipeline for WebGL. And you notice I mentioned like this concept of uniforms instead of constants. That's what this is over here. You have things like time and the matrix, which is basically the space that everything happens in. And these are uniforms. And then instead of variables, they have these things called varyings, right? And also attributes, which are like variables that are attached to things, I guess. Anyway, you have this fairly complex process that builds what you see. And this one thing to keep in mind, these are vertices, right? Never mind, this is a stupid diagram. The thing is, there's also things like animated fragment shaders. So the idea is first you shade the vertices to get like the color of the... So here's the vertices, right? These orange dots. I guess it's a pretty good diagram. These things define like the object, right? And you figure out the colors of those particular points, and then you figure out the colors of these spaces in between them. But animated fragment shaders are a whole other option. Instead of just like saying it's going to be this particular color, you can say, figure out what color space it should be in, and then animate the colors in that space. So it can get pretty crazy, and if you go to glsl.heroku.com, you can see some examples of it, and you will find out later in this presentation why it is glsl.heroku.com, unless you already know, in which case it will not be such a revelation. But the that stuff is on the hubs. This is an Octocat. This is actually the 3D model of an Octocat that was 3D printed, for those of you who are trivia buffs. But those of you who want to learn about WebGL might like this website called Learning WebGL, right? And the subject of this website is Learning WebGL. And it's got lesson 1, which is a triangle and a square, and it is 197 lines of code. Now that's including HTML, but it's actually an underestimate. It's actually over 197 lines of code, because this is line 198. Which is apparently a very significant line. It's a performant math library for vectors and matrices. So if you don't know what that is, matrices, right, there, if you got a grid, that's a matrix, and vectors is like physics. So take away the HTML, take away that giant line, you still have about 150 lines of JavaScript and GLSL, which you will find out about in a moment. This is including white space, okay? But you remember the name of the presentation is WebGL, what the hell? This is why, right? 197 lines of code to draw a circle, a triangle and a square. So WebGL has incredible power, but is perhaps excessively verbose. And this kind of comes down to the fact that JavaScript is neither Java nor a scripting language, right? Sorry, I had to, right? Yeah, Java, what?
Marketing.
Sure.
Marketing.
Okay. Yeah, that's where it comes from, right? I mean, JavaScript is just like the worst name for a language ever. They might as well call it like thing which does not run on computers, because the entire name is a lie. But someone who did decide to discuss this is Scott Hanselman, and he was like, JavaScript is assembly language for the web. Yeah, I'm going to skip that part too. The point is, you're basically talking to the GPU at this point, and you have to be very verbose with the GPU because it has to be, you know, incredibly specific, because you're going straight to a processor, basically. So anyway, you have 150 lines of JavaScript to do this triangle and this square. 24 lines for the DOM, 58 for shader setup. There are only 2 shades, black and white. In addition to those 58 lines to set up the shaders, there's another 17 lines of GLSL, which is a C-like shader definition language. It stands for Graphics Library Shader Language, which again just seems a bit too generic to me. But enough complaining. The point is, there's a lot of lines of code just to do that stuff. So you have this very sophisticated domain. It benefits you to get a sophisticated library. And the long story short, for the at this moment, in my opinion, Three.js for the win. There are perfectly good reasons to dive deep into WebGL, but I think if I did in this presentation, it would be as baffling for you as it would be for me. But it would not be as much work for you as it would be for me. So I didn't do it. Anyway, this guy here where the TIE fighter, you remember him, right? He's going around in a circle, right? That's 125 lines of code, right? So with Three.js, right, and it's mostly cut and paste, I'm not gonna lie, but this is less code than a triangle and a square. So I'm going to get into that code in a minute. Most of it came from here, so I figure I should own up to that. You can also get tons of examples on the Three.js website. Domain knowledge. Oh yeah, so if you don't want to get Cinema 4D to play with and create your models before you put them on your web pages, Blender is free. Cinema 4D costs about $3,600, so Blender is cheaper than that. This is a great website. I don't remember why it's here. Oh, why don't I show you this great website? I'm really sorry. I usually use lots of notes. I still haven't figured out exactly how to present without notes. This website is the most amazing source of domain knowledge ever. This is all WebGL, Three.js. And he explains it in detail. And I have to tell you, like, before I made this presentation, I read this entire explanation of how all that you saw, how it worked. And I didn't understand a word of it. And I went back and I've been, studying 3D graphics, and I've been, working with WebGL a little bit, playing with it. And now I understand like 1 word out of 5. So I'm like, yeah. Anyway, easily pleased, I guess. That uses GLSL quite a bit. Oh yeah, and it's like incredibly generic, but there's magic inside. So yeah, domain knowledge basically comes down to 2 things, right? You have to understand the 3D graphics paradigm. The paradigm used by Cinema 4D and Blender and Three.js and WebGL is used by like, Maya and whatever else there is. All the 3D software basically uses the same body of knowledge. So to do anything useful with Three.js, you need to understand this paradigm. And then step 2 is weird math, right? Just understanding what kind of equations can cause interesting results. And one really good way to find that out is Grapher, which is built into, OS 10. If you have a Mac, you have Grapher, and you can just throw in weird equations and see what they do. But this is another place to get more info. Udacity has an entire course on this. It's put together by Autodesk. It's quite good, actually. Anyway, 125 lines of code. Let's check it out. Here's this TIE fighter, right? So it's a bit, a bit false because there's more than 125 lines of code because you start off with requiring some things, right? So whatever. I lied. Three.js, right? Obviously. STLloader.js. So STLloader loads STL files. Something interesting about STL files is they're not actually for putting things in web browsers. They're mainly used in 3D printers, which means that if you have a 3D printer, you could write the software to control it in JavaScript if you felt like it, which I have a feeling someone somewhere around here is going to feel like doing sooner or later. I feel it in my bones. But yeah, so STL is mainly used for 3D printing. And this is just a furniture design done. I know it's one of these things. Furniture design done in Cinema 4D, which I just think is cool as hell. Anyway, there's also OBJ, which you load with the OBJ loader. JSON. This is not very widely used, but you can actually do your 3D modeling in JSON now. You do a little bit of CSS just to make the, to make it full screen. And, oh, what happened? Hello? My, did I? check, check. Woo! Okay, yeah, I'm back. Yeah, and then you make a little div for it. And at this point, you've done everything that you can do without domain knowledge. So we'll get into some domain knowledge. This, in the 3D paradigm, this is called a geometry, right? I find that weird because you don't look at a bird and say, look at that biology. But this is what you do. You call this, I think it cut out again. I'll just yell. You call this a geometry. Oh, I'm back. Okay. And one excuse I can find for, calling an object a geometry is that every one of these things has their own set of axes, right? I think the batteries are dying on this thing, dude. Yeah. Yeah, it's empty. Anyway, axes. I don't know how this is going to go because the batteries keep cutting out, but I guess sometimes I'll yell and sometimes the mic will handle it, and hopefully we'll achieve a balance of some kind. Anyway, I'm worried what happens when I'm yelling and the mic suddenly comes on. I hope your ears don't bleed or anything, but oh, wow, this is a big... Well, I'm just going to keep going. So, axes, right? What? Okay, no, what? Oh. He's got the mic on the desk. Oh. Oh, there's another one. Yeah. We do this whole thing. Okay. So, no. Hold on. Hold on. Hello? 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 Oh. I think it went down my shirt. Hello? How's this? Okay. I'll just yell and look to the left a lot. Okay. So, where was I? It's got these axes. So the thing about this is that when you tilt the object, the axes tilt with it. And it's kind of good to remember that, because otherwise you could tell this thing move 20 units along the y-axis, and you're expecting it to go straight up. And instead it goes like this, and you're like, what happened? So, yeah, axes. Anyway, this is a scene. I don't think it's working.
No, it's working just fine.
Sorry. This is a scene, right? This is just the term. And the first thing you do to create a scene is you add geometry to a material to a geometry. So you see how the TIE Fighter has parts of it that are gray and parts of it that are black and parts that are sort of a glowing white. So those are three different geometries that are, three different materials applied to the same geometry. And when you have a combination of at least one geometry with at least one material, you have a mesh. Okay? And then you add a light. Oh yeah, I'm going to demo really simply, right? Here you have a thing. Oh, I can't get to the lights, so you'll just have to imagine. You know what light is? It's like that. Okay, and then, you also add a camera, which I'm also not going to bother to demo, but you get the idea. There's got to be a camera in there. Okay, so here's how you create a camera. First you say, new camera, right? And you set it to a position, an X, Y, and Z, and you have it look at a particular point, right, which is also specified with X, Y, and Z. And these are the args for creating a camera. You give it a field of view, an aspect ratio, a nearest plane, and a farthest plane. And that's for the perspective camera, which is what you would expect like a camera to be. There's also this weird option, an orthogonal camera, which is like completely flat. It's useful for backgrounds, but you could also use it to create a scene that was built like one of those orthogonal view video games, which is a very unusual method. Anyway, here's how you create a light, right? It's just 3 lines. You create the light, you give it this is a hex number, right? Just like CSS, except you pass it a number instead of a string. You give it a position, and you add it to the scene. And if you're paying attention, which I doubt, when it says scene add spotlight, you might be wondering, where's scene add camera? That's going to make sense in moments, hopefully. So this is how you create the renderer. You just say like new renderer. You make it a WebGL renderer, but you could make it an ASCII renderer in the past. They took that out of the rendering category, and they just decided to make it an effect because it's ridiculous. Anyway, you create it, you set a background color. Set clear color means set background color, and you give it a size. And then you also say shadow map enabled, which is a little bit of a pitfall. By default, there's no shadows because it's kind of murder on your GPU for the browser. This is a cost-saving measure for now, but those of you who have done sort of any kind of engineering for more than about 6 years know that typically something that is a cost-saving measure for now lives forever. So my guess is that 10 years from now, someone's going to be doing WebGL and needs to remember shadow map enabled. So there you go. And then you add it to the DOM, and you have a little render function. I'm going to try clipping it again. I hope you're ready.
Go ahead.
Okay. I guess that'll work. Is that working?
Yeah.
Thank you, thank you. Yeah, here. This will work. Okay. Yeah, so anyway, you got a render function, and we'll just ignore this, most of it.
You're fine.
Yeah. What's that? Sure.
Switch that one off. You can leave it alone.
Oh, okay. Yeah.
Okay.
Hello? Hello? Okay. Yeah, so what you do here, long story short, request animation frame render, right? So you might be familiar with the old and busted, new hotness dichotomy. Set interval is old and busted, and request animation frame is the new hotness. Hopefully everybody knows that. If not, check this book, which is a good book, even though that guy is obviously a samurai, not a ninja. There's all, I mean, he's in disguise. Yeah. There's also like a brief excerpt on Resig's blog, and it's pretty good. Anyway, it explains at least why request animation frame needed to exist. So what you do is instead of saying set interval, you say request animation frame and pass the rendering function to it, and then you just ask it to render the scene with the camera, and there's the camera, right? And this is so that you can render the same scenes with multiple cameras. So this is the code that actually pulls in the TIE Fighter, and you can see it's fairly simple, right? You have an STL loader, you load it, and then this, you pass a callback function, the geometry. You create a material, and you put it in a mesh with the geometry. You just give it a little rotation and a scale, and add it to the group. And this here is what has it rotating, because remember, it's turning around and, oh, hold on. If you've forgotten, this is what it's doing, going round and round in a circle. And that is accomplished with this little thing here. Group rotation Z just continually adds to the rotation, and of course, that results in going around in a circle. Oh, there's also a version with, hold on. I wrote a version that has control from the keys. It's really just amazing. And by amazing, I mean mostly unimpressive. Here it is, and this is me moving the keys and moving it manually, right? Yeah, it's going to change your life, isn't it? It's just unbelievable. But yeah, this thing was actually just devastating my computer, and I thought it would crash, but it seems to be fine at the moment. This code is about as obvious and simple as you would expect it to be. It's just a simple key listener, right? and it modifies the rotation of the position accordingly. And then that is unnecessary. For the sake of following my plan, where it said demo the cube plus key control, here it is. This was my backup in case the TIE Fighter model killed my computer. It's pretty amazing. Anyway, this plan doesn't seem to be working, so I'm just going to change it. This I wrote on the plane. I flew here for various reasons. And what this is, oh, hold on. Let me show you where that came from. No, it's too much work. This is just a wireframe. Basically, I took an STL loader thingy, and I built this shape in order to create like an interesting effect in Cinema 4D. And then I threw it in, and I just have some code that changes the rotation and occasionally randomly teleports it to new locations, right? And then this one is called balls, right? Because these are a bunch of balls bouncing around. All that's happening here is they have edges, right, for X, Y, and Z. And if it exceeds the edge, the velocity is reversed, right? So instead of storing an actual vector, all I'm doing is X velocity is expressed as a number, and you add that number to the X position, right? And then if it hits the invisible wall, you multiply X velocity by -1, right? So it keeps going until it hits the invisible wall, multiply it by -1. Now when you're adding it to position, you're actually subtracting it, so it moves in the opposite direction. And yeah, this is actually a fairly simple thing to do. I can show you the code for it. It's going to be in here somewhere. Probably on my computer. That's where I'm expecting to find it. Yeah, okay, so up here, I created a function called createSphere, right? That's this. And it creates a sphere geometry, and the sphere material is called a mesh basic material, and you just pass a wireframe true argument to get the wireframes, which to my eyes, they look cooler. Like a completely perfect wireframe looks cooler to me than like a poorly implemented shader, you know? So I don't know, that's cool, and they're much, much faster. Anyway, then it just adds you know, a random velocity in each direction and a semi-random, well, yeah, a random position, and just adds it to the scene. And then you know I said that there are like invisible edges that you add into the code. Normally when I do something like this, the edges are just going to be, you know, the max width and the max height. So I tried, you know, window.innerHeight and window.innerWidth and stuff like that, and it just failed completely. So I created these variables, WTF ceiling, WTF edge, and WTF z, which stands for the, you know, the z distance. And then this is the render. And if the stuff exists, it goes through the list of spheres and adds the velocity, as I said, and then it just detects the edges and bounces off them if they're there, and then proceeds as normal. And I'm going to see if there's anything else in here. Oh yeah, the planets. This is really cool. Hold on. So this, I cannot claim any credit for. I just found it. But can you see that? It's two planets with a background. So this is an exception to the idea that you just make a scene and you point a camera at it. This is actually 3 scenes. The background is handled with an orthogonal camera, and the other two, I think they just have one perspective camera pointed at them. But it is a very strange quirk that we are apparently able to see through two cameras at the same time and view three scenes. So I don't know. That might be interesting. Yeah. That's almost all I got, except I got a cool video, which is not really related. And you can't see it anyway. Okay. So yeah, I did this in Cinema 4D, and I was trying to figure out a way to do it in WebGL. But as far as all I got was the balls. I mean, yeah. Okay, so that's, I don't know. Any questions? Thank you. Thank you. Yeah.
How does a TIE fighter look on a mobile device?
How does a TIE fighter look on a mobile device? As I understand it, Chrome for Android supports WebGL and is unique among browsers on mobile devices in that regard.
Have you tried it?
No. I don't have anything wrong with Android, but you know, it's a rumor that I hear floating around the interwebs. Anyone else? Questions? What? Oh, I can't. Oh, sorry.
How is the cross-browser support for WebGL right now?
Well, your best bet is Chrome. I don't really know. I do know that it used to be that if you would, because I pretty much only use Chrome anyway. This is probably not the right answer, but I do know that there's a lot of sites where you'll go to, you know, and it says, please come back with Chrome. And that doesn't really happen anymore. I'm pretty sure that Firefox and Safari are pretty good with it. Although, I mean, I wouldn't want to find out about Internet Explorer.
IE11 does it, actually.
Oh, really? Okay. IE11 does it.
It's pretty good. Support is pretty good.
Cool. Questions from the audience? For the audience. Takes all the work away. Thanks.
Like with the wireframe balls that were bouncing around, like you can control their acceleration too. Like how much control do you have over those graphics?
Well, essentially total. You could, I mean, if you wanted to change their acceleration, what you would do is add, you know, you could either have like a constant factor called acceleration, or you could have each sphere have its own acceleration attribute, and maybe they have random amounts of acceleration. So the way it works right now is you have, you know, position x plus equals velocity x, right? You just add the velocity for that direction to the position. You would add, I don't know, say you wanted an acceleration global, you would just say acceleration equals 0.35, whatever. You know, that's just like, and then you would multiply, you know, velocity times acceleration and add them both to the position. And then that would, actually the math for that is probably wrong, but the point is you just figure out the right math. I don't know, I'm just figuring this out, you know, in my head right here, but you have total control over that. You can change all that stuff.
Okay.
Okay, thank you.